Cool. Hi, everyone. So, as Sue mentioned, I am Nikita. I'm a PhD candidate at UCL. I'm doing my PhD. PhD candidate just means currently doing my PhD. I don't know why they call it a candidate, but I'm currently nearly at the end of my second year of my PhD in AI for healthcare, and I work on like genetics and drug development and how we can use AI to try and find new drug targets. But I'm not going to talk loads about that. I'll get, if anybody is interested in that space, I'll get Zero to circulate my email address and phone number and whatever, and you're more than welcome to contact me. But I just thought today, I assume that people are coming from really different backgrounds. If you're an expert in AI, then I'm sorry, this might be a bit boring to you, and please don't call me out on my mistakes in public. You can do it later. But if not, then hopefully this will be a useful overview to what AI is and what we mean by it and how we're currently using it. And how you might, I don't know much about construction, truthfully, but hopefully how you, in general, might be able to use AI to help you. So yeah, here I am. I'm a former software engineer. For some reason, left that nice paycheck and went back into industry. Academia. And yeah, as I said, I'm a PhD student, and my interests include reading and running, which I took a little bit too seriously and accidentally got into the London Marathon next year. So if anybody has any tips about how to make that less painful, I'm all ears. So just as like a little overview into what I might be speaking, I will be speaking about today, is firstly, what do we mean by AI? It's quite a conflated term. Hopefully, I don't think I have the right answer, but hopefully we can get a little bit more clarity into that. What the different types of AI are, machine learning, which I think is probably most likely the most useful version of AI for everyone, here at least, where AI is today, and what are the challenges and considerations that we might need to think about when we're using AI, and what's next. So I did a quick Google and like pulled together the common description of what AI is, which is the use of computers and technology to mimic cognitive functions associated with intelligent beings, which is a very broad term, and kind of similarly, AI is a very broad field. So these are just a few examples of what AI might mean. So the first is a really simple chatbot. We've all used them. You try and go on like the British Airways website and you're like, what is my flight number? And it will give you back your flight number, or it might give you something useless. It might give you 4 more options of what to talk to you about. And that's a really simple rule-based system, and it's called an expert system because it has expert knowledge in its domain. A contested term, but really simple, still AI, because it's mimicking human behavior. It's not learning anything from you. It's not been trained to learn anything, still AI. Search algorithms. So we've all heard about AlphaGo, etc. But the original algorithms which beat humans at chess actually weren't complicated machine learning algorithms. They just exhaustively searched many next moves, chose the best one, played that. No complicated neural networks or anything like that involved, still AI. And then I guess these two at the end are what we nowadays maybe conflate with the term AI. Machine learning and natural language processing, there's a lot of overlap between all of these, but I think these two are the ones that maybe people are more interested in. So I've circled them nicely with a red circle there for you. So yeah, I think I'll spend most of the time talking about machine learning because again, like I said, that's probably what's most useful. So by machine learning, it's saying a lot of stuff here, but all it's basically saying is machine learning is giving a machine or a computer data, allowing it to learn things, and then produce some kind of output or behavior that mimics human behavior. And yeah, I think that last sentence is really important. It's all about creating and implementing algorithms that facilitate this. And so in case you're not familiar with how machine learning kind of works, a very simplified overview. But so you feed an algorithm that you've written some data, you train it, which basically means tune it, let it learn some things from the data, let it extract some patterns, see how well it works on some data that you've given it here. So you've trained it, you've got some kind of model, you're giving it some data saying, I want you to tell me what you've learned about it. You see how well it's done. If you're happy with it, you're good, that's your model. If you're not happy with it, back to giving it more data and letting it learn some more things. And this is the part that is really resource intensive and takes a lot of time. like how do you keep going until your model is good enough to do what you want it to do. And there are various types of machine learning. I won't go into too much detail because we can get quite technical, but there's three main types, I would say. You can split these into more subcategories, etc. But the three main types are supervised learning, which is maybe your like classic type of machine learning where you want to be able to give, you see those pictures of, this is a cat, this is a dog. I give it to my machine learning algorithm, it tells me whether it's a cat or a dog. So you're training it on things that you know, and you're saying, please learn how to do this yourself. That's a very simple example, but a good example of how that works. Unsupervised learning here is mostly, the main application of it, I would say, is clustering. So give it loads of data, and I'll use an example from my field, which is healthcare. So I'll say, I've got all these diabetes patients. Can you please cluster them based on subtypes of diabetes? I might not know this. I might not be able to see using my bare eyes like how these cluster, but I want you to find some patterns and tell me what the clusters are. And then I can have a look and see what's interesting about those clusters. And the final kind is reinforcement learning, which is what's used in the more modern and sophisticated game playing algorithms. So I give my algorithm the current state of the world, let it do something, tell it how good it is, if it did that or not, and let it come back and try again, and just keep doing that. And you reinforce the good behavior until you get to something really positive. So those are three main types of machine learning. And then I guess what we actually are all interested in nowadays is deep learning. It's like a bit of a buzzword for good reason, because where in machine learning you have to take some input, tell your algorithm what's interesting, let it learn some more things and give it an output, deep learning does that all itself. And what's really good about that is you might have data with really rich features and really complex relationships, and a deep learning algorithm is far better at picking that up than a more simple machine learning algorithm would be. And the way with deep learning networks are usually set up are these layered neural networks, which are based on the neurons in the brain, very loosely, but they capture all the information and relationships, train them, retrain them until they're good. Same principle, train them, retrain them on loads of data until they are good enough, and they can predict something. In this, it's car or not car, but you can imagine something far more complex than that. Any questions so far? Or anything? No? Okay, cool. Thank you. So this is very much a whistle-stop tour because I'm limited on time, but I just thought, what are the kind of really interesting things that are happening in AI in industry right now? And a big thing at the moment, I think, something that we're hearing a lot about is generative AI. Now, it is the case that the stuff we hear about is the stuff that is causing maybe controversy, or it's making a lot of money, or any of these kind of things. One of the things is generative AI. And this on the left is an image produced by a piece of software called DALL-E. I don't know if anybody's ever tried it, but you basically give it a prompt and you say, please, can you generate me a picture based on this prompt? I did not generate this one. I think this is like a robot making a painting or something like that. You can imagine you give it some arbitrary prompt. And what's really nice about generative AI is that, and again, I can talk mainly from my own experience, but in health technology, we have this issue where we don't have enough data. I mean, it's a good thing. We don't have enough people, for example, with a specific kind of brain tumor. We're happy about that. It does mean that our models are more limited by the amount of data we have. So we can use generative AI to generate new images based on the images we're giving it. One really good use case of it. And in educational technology, teachers are using it to generate, for example, notes or exercises. You can see there are potential downfalls with this, but it does show great promise. And another type of generative AI is where generative AI meets the cross-section of NLP is ChatGPT, which we're all very familiar with. It's trained on many parameters, many words, and it's able to, you can give it a prompt, it's able to generate unlimited amounts of responses, basically. Again, whether they're good or not, questionable, but it's able to do it. And again, there's some really nice applications of NLP in different industries. So again, in health tech, doctors' notes are often, either too verbose or not verbose enough, not clear basically, and it can be, which can be a problem because healthcare has many steps and blah blah. But there's some really nice applications of using natural language processing to summarize doctor notes and make them a kind of more standardized and readable format. Multiple industries, I'm sure many of you have heard of sentiment analysis. So for example, I don't know, Exxon might want to scrape Twitter and see what's the general public sentiment. Political parties, very, very on topic. Many of them use sentiment analysis to scrape Twitter and see what the general sentiment towards their policies might be. Can very quickly run that through an NLP model and get a positive or negative output. And one that I actually found out about recently, which might be of interest, is manufacturing, using it for predictive maintenance. So using codes, etc., from machines and using that to predict when, like to preempt basically when you might need to put a machine through maintenance, which I thought was quite a cool example. And then the final one, which again, I'm sure many of you are familiar with, is CV screening. So a lot of people at the moment use it. A lot of your recruiters will pass CVs or LinkedIn. Should I wait? Should I wait till the camera's back up?
It's gonna work.
It's okay. I don't need to. That's fine. But they'll pause CVs or LinkedIn profiles using these algorithms to see who their ideal candidates are. With every example I've mentioned, I'm sure you can see there are many pitfalls, and that I think there are a few things that you really need to consider. So the first thing, again, if you've ever worked with AI, this is kind of the first principle you ever learn, is garbage in equals garbage out, rubbish in equals rubbish out. Often data processing and making sure it's in the right format is the most time-consuming part of making an AI model. Making sure your data's in the right format, that your model can read it in, that it's standardized, all this kind of stuff takes ages, and it's really important because your model only knows the data you've given it, and that's all it can train on. And it's really important, like I say, it should be representative of the end product. So if you're training a model to predict, I don't know, flower or like bird migratory patterns in a certain type of bird, if you train it in a different type of bird, it's not going to be that transferable, and you need to be aware of that. And yeah, how's the data encoded? Often when there's a large amount of data that you want to feed into a model, different parameters need different types of encoding, and that's something that you really need to consider. Second one, computational power. Big models take big computers, and most personal computers just can't do it. You don't have, the amounts of data we're talking about, you just don't have the memory or the compute power on your personal laptop to do it. Even, I mean, I got given a nice shiny new Mac when I joined my PhD, not big enough. Often you need to invest in something like Google Cloud credits or something similar in order to run your model. And AI expertise or patience, I've written here. Knowing what to use and how to use it, it takes a lot of time. Training models take time. The iteration process takes time. And I think it's a good skill. I think you have to take the time to learn the skill if it's something that you want to do. And finally, I've just gone, what I think one of the most important things when using AI is to look for the pitfalls, because building a model is fine. Making sure it's a good model is very much not fine. This is a really good example. So one of the things you might find is, I don't know if you've heard this concept of black box model. So you give a model something, it outputs something, you don't know how it's done it. And this is a really good example that went quite public, where this research group had trained a model to recognize, I can't remember what it was, I think it was some kind of fluid in the lungs using chest x-rays, and they thought they had really good performance. And then they used it on another data set and they said, our performance is actually really bad. And it turned out that the model was actually picking out these, I don't know if you can see them, they're labels from the hospital that labeled which side of the lung it was, which part of the body it was or something, which obviously when you transfer it to another hospital is not going to work. So which is why the way they pick this out is by using model explainability techniques, which pick out the features in the model that have led to the prediction. And you can see if people hadn't called them out, you'd think this is a fantastic model, and then, yeah, it's not great, is it? Inequalities and bias. So yeah, I'll just explain what this is. It was I think it was a big Twitter conversation a couple of years ago, but there was this software that people had trained to depixelate images. So you give it a repixelated image, it restores it. And yeah, this nice picture, this picture of Barack Obama has been turned into this nice white man. So that's a direct result of not training. As I said, the training data has to be representative of the end product. If you train your model on all white men, this is the kind of thing that's going to happen. And that's something that we face in healthcare a lot, because most of for so many reasons, most of our data sets are really homogenous, and it's actually a really big struggle to get things that predict minority groups well. The environmental costs, if that's something, and I don't know, but I assume in construction that is something that you really do think about. This is a headline from I think a couple of weeks ago. It's very recent, where Google's emissions have climbed nearly 50% due to AI energy demand. They've obviously output some at least semi-successful AI models. I don't know how good they are. There's mixed reviews, but these massive computers that take massive parameters take a lot of energy, and it's having some pretty dire results. So I think it's a conversation that's going to pick up in the next few years, because they're really not meeting their climate goals. But I think as individuals, it's hard for us to have a huge impact on when this kind of stuff is happening, but it's something to consider. And I think there's one more. Yeah, where does your data come from? I'm sure you've seen these, I want to say like headlines, controversies about these very impressive new models that are able to predict so much stuff. But it turns out they're taking data from places where you might not have explicitly given them permission to. For example, you have like metadata tags on all of your Instagram posts, for example, which say where you were at what time. You don't even really know that's happening, but behind the scenes, that's data that they're able to scrape and take and train for their models. And it's actually something you really have to consider when you're training your own models as well. Again, I'll come back to healthcare. We have to make sure that whenever we use data, it's super anonymized. There's like 7 million data ethics protocols you have to pass through. There's no point training models on data that you're not allowed to use. It's not ethical and it's not fair. And yeah, I think the final big one is adoption and acceptance. And I think, so yeah, this headline is specifically for doctors. I think they are in a position to be able to reject AI, to be honest. They have a lot of, they're quite skeptical about it. And I think a lot of this has come from the way that AI has been perceived, the way that big companies are using AI. Obviously, we've seen deep fakes, we've seen ChatGPT doing insane things, and that's widely publicized. And I think it's kind of skewed how the public think about AI. Not their fault. If I didn't know anything about AI, I would think the exact same. But it does mean that adoption and acceptance of AI technology in the industry is extremely, extremely hard. I think the number of AI models that are in the NHS right now is less than 10 in the whole country, which, considering how many of us are researching it, is a little bit of a stab to the heart, but very understandable, because if it goes wrong, the cost is quite high. And I think that's something you have to consider when you're trying to convince people to use AI in their work. Especially if they don't understand it very well and have only heard what they hear in media. Oh, that's my last slide. I thought I had a thank you and goodbye slide, but clearly not. Yeah, that's a very, very whistle-stop tour. Thank you so much for listening. If you do have any, like I said, if you have any questions or comments or whatever, I'll get you ready to pass my details around. Cool, thank you.